So let's work out a few examples that involve counting methods and then translate those into probabilities. First, say we have a box of bolts and a box of nuts. The box of bolts contains 10 thick bolts, 6 medium bolts, and 4 thin bolts. Could happen. Then a box of nuts, let's say that contains, that has 7 that fit the thick bolts, 5 that fit the medium bolts, and 3 that fit the thin bolts. 1 bolt and 1 nut are chosen at random from each box. What is the probability that the nut fits the bolt? Okay, big time problem. You're stumbling around at night, you've got a box full of bolts, a box full of nuts, you pick one at random, it's dark. Well, what's the probability that those two things fit together? Okay, well, this is a classical probability, and we'll see that because we've got this event A. Let's call it event A, and that is the event that the nut that's drawn at random fits the bolt. Okay? And we are able to count the number of ways that A occurs, and we're able to count the total number of ways that any connection of nut and bolt could occur. Okay? So that's a classical probability. The probability of A occurring is the number of ways for A to occur divided by the total number of ways to draw 1 nut and 1 bolt. Okay? Regardless of whether they fit each other or not. Okay? Could happen. So the denominator is easy to calculate. Let's do that one first. Okay? So let's figure out the denominator here. Okay? We have how many nuts? Number of nuts equals 15. Okay? Number of bolts. Number of bolts in the box, that was 20. Okay? So how many different pairs can we make? Well, we first take 1 nut. How many ways are there to do that? 15. And then we take 1 bolt. How many ways are there to do that? 20. So 15 times 20, 300. 300 different combinations, 300 different ways to draw 1 nut and 1 bolt at random from these 2 boxes. Okay? Now let's talk about the numerator. This is a little bit more difficult, not too bad though. Let's think about the number of ways that we can match different pairs, and let's think about them from the thick, medium, and thin bolt perspective. Okay? So let's think about the number of matching thick pairs. Okay, so we've got a thick bolt and the nut that goes with that. Well, we said that there were 10 bolts that fit this description and 7 nuts that fit that description. That would be 70 different matching pairs that would get us a matching pair of thick for a thick bolt. Okay. Let's now think about the number of matching medium pairs. Okay. We said that there were 6 bolts, 6 medium bolts, and 5 nuts that match those medium bolts. So we have 30 different ways to pick out a medium nut and a medium bolt and a matching medium nut. Okay? Then finally, we've got the number of matching thin bolt pairs. Okay? We said that there were 4 thin bolts and an associated 3 nuts that fit those 4 thin bolts. Okay? That would give us 12 different matching pairs, 12 different ways to match a thin bolt and a nut that fits a thin bolt. Okay? So, what are the different ways for us to get a matching pair? A nut and a bolt that fit together. Well, we could have these 70, or these 30, or these 12. Okay, so the or implies plus. So 70 plus 30 plus 10. 70 plus 30 plus 10, or pardon me, 12. 70 plus 30 plus 12, which is 112. So in the numerator, we have 112. 112 ways to get a matching nut and bolt, and 300 different ways to get any kind of nut and bolt, regardless of whether it matches. So we've got 112 in the numerator, 300 in the denominator, and if we work this out, that is 0.3733. Okay? So again, we've got a box of bolts, a box of nuts with these characteristics. What's the probability that just at random, whenever we pick one from one box and one from another, what's the probability that those two fit together? 0.3733.